Well, here we go. Last day of the regular semester, and here are some of the last set of reactions that we have covered. And with this, what's the first thing we want to denote about this compound here? Way over here on the end. Yeah, that's important. So when that happens, that means it's either an ester, an acid, a ketone, or an aldehyde. And since it's on the end, okay, double bond any other spot means it's a ketone. Of course, if it's on the end, then it's an aldehyde. Now, this is also in your flow charts because this is the dichromate ion, just like permanganate, is also an oxidizing agent. So what that means is one of the things that we get aldehydes from is primary alcohols. And when that oxidizes, it forms aldehydes. And then if it oxidizes one more, well, then that gives us an organic acid. And what we're getting at is this. Remember, from your aromatic reactions, you would want to see, well, where are we starting? If you just see benzene, you know you start in the middle of that whole paper. But sometimes we will see something like, for instance, maybe there's a Cl on there, okay? And when we add something to this, halogens are both ortho and para directors, just like the last one, which is a nitro group, which is just a meta director, which means anything you add will either go onto here or onto there. So you want to see what it is you're actually starting with. So in this case, we're starting with an aldehyde. If it oxidizes one more time, which it will, we form our acid. Okay? And how would we draw this out to be an acid now? Of course, we still have our double bonded oxygen still there, but what illustrates an acid? Put an OH on there, okay? So in this case, we start with butanal, okay? The suffix is Al because it's an aldehyde, gets oxidized, we form an organic acid. All right, make sure, yep, we're still rolling. Good, good, good. All right, now we're perhaps into this bottom one's more familiar territory. Well, hopefully this one is too. This one is going all the way back to probably the middle of August. Just thought I'd throw this up there. This does not need a catalyst. Does this, do you think? Do alkanes, are they very stable or are they unstable? They're very stable, okay? So if this is what you see on the paper, okay, nothing results from this. It's no reaction. But should there be something underneath here, like perhaps a little bit of heat, okay, then we will get this bromine to attach to one of these two spots here, over here. Really doesn't matter, it's just gonna pop on that second carbon. Okay, so therefore, what was there, 6? Yep. So we'll go ahead and put them here. Okay. Now, what type of derivative is this down here? Okay, we want to review that too. How many carbons are in it? Well, here's one. And then how many more are in here because of this parenthesis? Okay. Oh, take 2 times 1 gives us 2. And this last one here gives us 3. So therefore, this is isopropyl group. All right, so just a little bit of a review we wanted to pop onto there. Okay. Can we erase these top two? We don't want to be going too fast. Not the second one, okay? Oh, shoot, I didn't kind of erase that second one. Okay. All right, so then this last one down here, first thing we want to recognize is, first of all, what type of alcohol it is. And what that means is, remember from prior knowledge, and I know you don't need to write this part down, because if that is on the end, that's a primary alcohol, if it's on the end, okay? Because we say X marks the spot, that carbon is attached to one more. Okay, if it's not attached to the end, say X marks the spot, this carbon is attached to two other carbons, therefore making that a secondary alcohol. And then finally, the last type would be, in what we see on the bottom, is if that carbon is attached to three others, making it a tertiary alcohol. Those really don't want to do a whole lot with anything. And it really doesn't matter whether you have a catalyst down here, whether you do or whether you don't, whether you have a dehydration reagent or you're trying to oxidize that, any one of those. If we see carbon, 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 we know that's a tertiary alcohol. Doesn't matter what we have here or here. That will not react. Okay. Because we've got a tertiary alcohol. Those can't dehydrate and they certainly won't oxidize. Okay. All right. So what can we do to change this to a no reaction? Well, we can't use this, but if we take this methyl group off of here, now we've got a secondary alcohol now. And if we look at our charts, we know that secondary alcohols are going to do something very specific. We still have all 5 carbons. Okay, so as we're looking at that, everything written over here is correct. Notice that hydrogen's gone. So we're still going to keep this oxygen. And if we remove that hydrogen, which we will, I got to change this too. I can't leave it like that. Put an oxidizing agent up there. And that hydrogen's gone. So when this oxidizes, that gets removed. That gets removed. Okay. And we've now got, it's not an aldehyde, it's not an acid, but it's a double bond oxygen anywhere in the compound, not on the end, making this a ketone. Okay. So we're just chugging right along here. Word problems, are they awful? Story problems, I should say. Okay. Okay. So we can go ahead and okay. So if we need to start with benzene, okay. So I'll try to keep this really short. Starting benzene, which we know is this. Okay. How can you make, okay, we'll do, we'll say methyl. Seems like we always want to use chlorobenzene. And we'll say parachlorotoluene. Okay. So we need to start in the middle with our benzene ring here. Okay. So what we're going to see happening is we've got to get a methyl group on there first. Okay. And with that, we can't just write it like that and say, oh, that's going to attach on there. We can't use methane. So we have to use Rx, an alkyl group, and the halogen we want to get placed onto there. Okay. So now what we see happening is this will react, and with this we need a metal halide. So we'll just go ahead and use some nickel chloride. So as that attaches, okay, now we've got our methyl group on there. Okay, so this is R, that is X. Okay, and through the process of this reaction, that chlorine gets taken off. Now we've got our methyl group on there. But notice we want methyl chlorobenzene. Okay, so in our next step, we're going to continue. And this is probably about 7 o'clock on your charts, if I remember right. So here's our toluene. So we need to get that chloral group back onto there. And we need to attach it onto here. So we got to do something very specific. Okay, now we want Cl2. Now, this is where this totally splits apart. Okay? In other words, it's on your chart, shows you where one goes one way, one goes the other. Okay? So what that means, since we wrote this first, we underlined that, we'll go ahead and do this one first. And what that means, if we put another metal halide down here, that's going to react totally different than with this. Heat would be the catalyst that we want to get this on here. So now, I'm going to do the structural formula. Okay? Or else you can just do CH3. Okay? But notice it says methylchlorobenzene. Okay? So what that means is since we're adding heat to this, now we've got that chloral group attached onto there. Okay? Because one of the things we always want to talk about is if you write it like this over there, we're saying that carbon has 5 bonds, and it can't do that. Okay? So that's where we get that from. Now, starting all over again, we really don't have to. Starting with benzene to get parachlorotoluene, we still need to do this process. And then, once we get that on there, Okay? It's the catalyst on there that will change things. Because if we don't add heat, this won't attach onto there. If we use a metal halide again, now we can get our parachlorotoluene. That will give us one. Where is the para position for that? Is it right next to it? Yep, down here. Now we've got our parachlorotoluene. Okay. And then, yeah, if there's still an equal amounts, you'd still have your orthochlorotoluene as well. Oops, it's not a very good addition sign. Okay. Any more direction that we may or may not want as far as alkanes, alkenes. We really don't spend a lot of time on the alkynes. Okay. Then from there we went on to aromatics and then wrapped up with the alcohols. Okay. Isomers, are they easy or difficult? Don't know until you see them? Yeah. Okay. Well, let's go ahead and take a peek at maybe an isomer or two. If we had hexane, C6H14. Okay, there's 6 hydrogens on the top, there's 6 hydrogens on the bottom, and then 1 hydrogen on each end. That's where the 14 comes from. Okay, so an isomer just means we're going to have the same molecular formula of C6H14, but it's just going to be a different structure. What's the simplest thing you could do to make an isomer of that would still result in this, but looks totally different than that? Chop it. So left or right? Okay? So that means I'm going to start with this one. It doesn't mean that this has disappeared, but don't put them there. Think you might know why? Yeah, it's part of the parent chain. You still have the same thing, it's just bent. So if it doesn't go on the first one, where would be a better place for it then? We can put them here. We still have 6 carbons, we still have 16 hydrogens, but we don't have hexane anymore. We've got something different. Our parent chain is what instead? It's not 6, but rather, that's pentane, but what type of pentane? 2-methylpentane. Okay, that's an isomer. Okay, we could still do another one, C6H16. Do what with this guy? Put them over here. Now we have 3-methylpentane. But we can't go that far because then it's just the same as this one. So the next thing you could do, make an ethyl group if you wanted to. Okay, we're going to chop him off there. Wait a minute. Nope, that's still, we don't have enough carbons to make an ethyl group. Okay, so we're going to have to put him back on. Okay, we did want to chop him off, but we just put him here and here. Now we'd have 2,2 dimethyl, not pentane, but rather 4, which is butane. Yep. That is isomers. Okay? No, no, no. We just tend to struggle with them because maybe we just don't deal with them enough. I don't know. So I think out in the gallery here, are we glad we're not partaking in this? Okay. I think you still would do better than what you think. Throw me a bone here. Just lie to me. Okay? Was that confidently, though? Yeah. You know, maybe if we took this, it would take the curls out of your hair, or to put me even more curly. Put gray in your hair, too. Okay? Well, that's not so bad. It just means it's just losing composition of color. That's all. It's still hair. And it's not necessarily a bad thing either. Okay? I can't argue with that logic. But believe it or not, you don't know. You might be seeing this again a year from now, 2 years from now. You don't know. Okay? Okay. Okay, maybe more than likely. No one's going to argue with that, I guess. I can't determine that. But the last thing, I think everyone would agree, we do want you to be successful when you leave this building. Okay? We don't just make all this to ha, what can I do to really confuse them now? No, that's not our goal. I mean, it may come across as confusing, but it is our intentions that we've prepared you for all this. Because I'd like to think there's no surprises on there. It's just like, God, I remember going over that. I remember seeing things like this. I just need to open up my toolbox and continue to move forward. Anything that you can think of. Like I said, we did alkanes this semester. We did alkenes this semester. There's no alkynes on there. We got to chop it off somewhere. Okay. Then there's aromatics on there, aromatic reactions, aromatic naming, and then we wrapped up with the alcohols, which means you still may have to name aldehydes and ketones, but we have done that. You just follow the same rule. Find your parent chain, look for the organic family that you have, whether it's an alcohol, a ketone, an aldehyde, and proceed forward. Like, for instance, I think it really threw you people for a loop when it said, name and draw the simplest aldehyde. Okay? So how do we know we're dealing with an aldehyde? Okay? It's got a carbonyl carbon, so it has to have at least that. And I think probably what threw people off the most is they're just not used to seeing this, thinking typically aldehydes only have one hydrogen. This has two. Well, yeah, that's kind of an exception to the rule. This is formaldehyde. And if you walk over into the lab, you can smell something very similar. It's what's going to preserve the flesh on those cats. That's what formaldehyde does, so it doesn't tend to deteriorate. Then when it came to the simplest ketone, we can't do that because that's still an aldehyde. So we have to do that. That gives us our ketone. And then, okay, so that's what we mean by functional groups. Okay. So I can't think of anything else. I can always put more examples up there, but it's just doing more of the same things that we've covered all semester. You might be thinking, I have no idea where to start looking at this. Well, I don't know. Maybe just pick a random day on the Science Channel. Maybe go through there. And it's not like, geez, it's 30 minutes long. I don't want to be. No, you don't have to look at all 30 minutes, but might be something worth your time. But and I don't think we're asking a whole lot. I mean, it's just a little bit of time on your weekend. It just depends how much time you want to put into it. So I've got nothing else unless you can think of something. Oh, probably 15 to 20. Is that enough? That's more than enough. But see, the more pool you have to pick from, then the more, I'm not saying you have more leeway for making mistakes, if that makes any sense. Because if there's only 10 on there, ooh boy. More work. That's what we like to hear. Yeah. Do you hear that, Olivia? More work. Yeah. See, everyone's happy now. If you want to frown, that's okay. Okay. Nothing else. Okay. All right. Okay, well, let's go ahead and do the last thing here then. So, which famous doesn't even look like an A. Which famous baseball player was traded to New York, is actually from Boston, and has a candy bar named after him? His name was blank. I mean, you gotta go back a century, so quite a while ago. And let's see here. Okay. Can't write today. Oh, I think we can all attest to this. It's a kid's baseball movie. I think you look up any quote, it just says, "You're killing me, Smalls." It's entitled The Blank. I see some of you wearing lifeguard sweatshirts in here. Is that just a brand, or are we an actual lifeguard?
Like if you go to the beach, usually there's like a lot of lifeguard stuff. And they just have like the top or like the city or yeah.
No one in here is a lifeguard at the pool here.
No.
Oh, okay. Was it? Is it Brittany Pfeffercorn from? this movie. Maybe no one knows what I'm talking about here. Okay, well.
We all know what you're talking about.
Oh, you do?
We've all seen that movie a ton.
Okay.
It's like a classic.
It probably is. Yeah. Yep. 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 How do I want to say? Who jumped into the pool and faked drowning?
And you spelled pool wrong.
Oh, I put pole. I was just seeing if anybody was paying attention. I guess I didn't need to. So, drowning in bonus two's movie. So the answer to this is what we're talking about here, but it's this one young man who jumped in the pool and faked drowning. And what's funny about that is, of course, at the end, I think them two get married. Okay, that's all I've got for today. So, all right. We will catch up to you next time.